Hi, in this video I'm going to talk about a project about digital education. Basically, if you want to learn a new language, you have to read text about that language, but often those texts are not adapted to the level you want. So we're trying to create a tool that would allow you to find the texts that are at the level that you need. So you would just input the text in somewhere and it would give you the level, or you would put your level and it could even give you text to read. And to do that, we use the Wolfram language, which is a simplified coding language that allows us to create easily classifiers, which then enable to do that. So to tackle this problem, we had first a dataset provided to us. The dataset was made from sentences and their difficulty level already graded. So the first thing we had to do was import our dataset into the Wolfram, and we had to clean it a bit since every second line was empty. Then we also had to put it into the right format of dataset of Wolfram. Once we had this dataset, we also divided it in training set and test set. Because if you use the whole dataset to create your classifier, then you might have a problem of overfitting. Overfitting means that your classifier really classifies well your dataset, but then it takes outside data, so the text that we would provide it later, it would be completely wrong since it's over specialized in the dataset you provide. Here with the test set, we provide a test to see if the accuracy outside of what is already seen is good. Then we created classifiers with the most usual algorithm that you can find. We had a list of 6 algorithms from logistic regression to the Markov method. Then with the training set, we created all the classifiers. And with the test set, we tested the different indicators about our classifiers. And you can see the results in these data sets here. So you see the precision, which is the number of good precision on the number of the predicted A1, for example. If we're talking about the difficulty A1, it would be the number of well predicted A1 sentences on the number of all the predicted A1 sentences. Then the recall is the number of well predicted A1 on the total number of A1 sentences in the dataset. And then we also added the average of the accuracy of the whole difficulty to have a clear indicator of each regression of each method. So we saw that the logistic regression was one of the best one with Markov and gradient boosted tree. We will choose to use the logistic regression later. Then we also wanted to see what were the errors that were in our classifier. So we took the 3 worst classified examples and we tried to see why would they be badly classified. So the first example, we see that the sentence is only one word, non, and it is an A1 sentence. But our classifier predicted an A2 level. Here in the probability, we can see that it's 100% sure nearly that it's an A2 sentence. Here we imagine that it may be because of the concept of negation and it assign a higher level to negation where it should be way simpler. Then the second example is La texture est parfaite, which is a B2 sentences but that was classified as A1. We think that it was classified as A1 because the sentence structure is really simple. So here we see that it doesn't take into account enough the vocabulary and the important vocabulary that is in the sentence, because the word texture would be a more complicated vocabulary. And then finally, with the last example, we see that it's truly a B2, but it was classified as B1. So already here the mistake is not as big, but the problem is that in the classifier there's no way it could be a B2. Here we think that it classifies it a bit lower because also so a lot of words are simple and the structure is still quite simple. Once we had those basic models seen, we tried to find solution to increase the algorithm accuracy. To do that, we decided to add variables. The first thing we did is to check the stop words. What are stop words? They're words that are really common in every language. So for example, the pronouns when you say I or you, and all those words don't really indicate the difficulty since you use them whatever your level is. So to do that, we had two methods. Our first method was to take our dataset and take the most common 100 words that were in the dataset, because those would be the words that matter the less. Then we also imported another dataset of stop words that we found online and that we adapted to our case, looking at our stop words, because it represented well all the stop words that we forgot. We decided to use the one that we created as it was more of our creation, and the goal of this exercise was to use what we could do. And from that, we added a third variable in our dataset, which was the sentences without any stop words, which would then increase the importance of the vocabulary and the difficulty of the vocabulary. Then our second idea was to see if there's a correlation between the length of the sentence and the difficulty. To check that, we created a bar chart, and there we saw that there was clearly a correlation as the C2 sentences were way longer than the A1 in average. And since we saw that, we created a new variable in our dataset, adding the length of the sentence. So you had a fourth column here telling the length. So here you would have 1, 2, 3, 4, 5, 6, 7, 8 words. So you would have an 8 here in the length. This would put importance on the length of the sentence. Our third thing that we used to increase the accuracy and also partially to increase the classifier timings, because it took a lot of time to create any classifier, is to use word embedding. Basically, we used tokens, the tokens version and the glove 100-dimensional word vectors trained onto it. So why do we do that? It's because computers uses numbers to do a regression or to do a Markov method or a gradient boosted tree or anything. Basically, it uses numbers, not words. So when we create the classifiers, the Wolfram language automatically uses the words and translate it into numbers. Here we do it ourselves according to our rules, which speed up the process. And once we have the numbers, it's way faster to calculate the classifiers and to create them. We tested the first method as it was to test our theory that it would be way faster and it would give better results. It was indeed really fast, but the results were not that better with token as we think that it used it automatically before us choosing it. Then we used the second encoder, the glove method. Even though it was trained on an English dataset, it still gave us a better accuracy, so we chose to keep it and to add it. And finally, we used more data. So we went online and tried to scrape data about sentences and their level of difficulty on language forums and language websites. And we added around 200 rows of data, 186 to be precise, to our first dataset to increase the accuracy. So with those four methods, we were able to increase the accuracy about 10%. So we went from an accuracy of around 40% to 50%, which is not a big increment, but which is good in our case. Once we had found a way to increase the accuracy, we tried to create an interactive interface for users. So here we used a simple function from Wolfram that enables us to create an interactive interface where we simply put a sentence and it gives us a result. For example, j'aime les pommes. It would give me the level that it predicts, A1, which is really simple. Then this would have been the product that we would have used to analyze the text. And then part of this exercise was also a competition on Kaggle. So I'm going to quickly go through what we did to complete this competition and to find the best accuracy that we could, as the key indicator to win the competition was the accuracy. So we did the same thing as I explained to you before. We imported the data. Then we built the classifier using encoding and the length of the sentences. We also used a really important part here, the seed random. Because when you divide your data set into a training and a test set, you don't know always which will be the result, since it's random. And to maintain and to be able to modify this result, we tried with different seeds, which gave us a fixed accuracy that we could reproduce over time. And then once we had this accuracy, we imported the data that was on Kaggle and that we needed to test, and we encoded the data. We add the length also to the data as a variable, and we applied the classifier that we created before, and then we exported the result to upload it on Kaggle. And that's how we were able to build this simple algorithm to find the difficulty of a sentence. I hope you enjoyed the video. And in addition, if you want to find the notebook, it will be available in the description.